And since I'm a last-second fill-in for Nick Nisi, who is unfortunately really ill today, I don't know exactly what you guys are looking for or what your experience levels might be. So how about we just kind of go around the room, you tell me, do you know anything at all about web technologies, whether it's HTML, CSS, or any other programming language? We'll start with Art.
HTML, CSS, Java, a little bit of JavaScript.
Cool. Yep. Go ahead.
HTML 1.0, HTML 5, intermediate on JavaScript, a little copy, a little PHP, CSS.
Cool.
Hi, my name is Wonpeng. Pretty much the same thing, HTML, JavaScript, CSS, Java, PHP, XML.
Cool.
Hello everyone, my name is Alicia, and basically I know the same as guys just stated, HTML, CSS, JavaScript, just intermediate, I would say, jQuery, WordPress.
Cool. Trey? That's a lot.
HTML, CSS, Java, JavaScript.
Oh. Well, that's awesome. Cool.
Yeah, HTML, CSS, a little bit of JavaScript, jQuery,
Cool. Just beginner. Go ahead.
HTML, CSS, a little bit of JavaScript, PHP, and SQL, and Java.
Wow, that's a big list. Same? Cool. So got a pretty good mix of different skills here. For some of you, a lot of what we're going to talk about in the next hour is probably going to be a little bit of review. But as I like to say, something will come up that you probably don't know. Even if you are pretty comfortable with JavaScript, something will hopefully come out of my mouth that you've not heard before. That would be the ultimate goal. Since I don't know what we're going to be doing exactly for a development environment, because in any language, just like JavaScript, there are lots of different tools you can use to help you. I'm just going to do all of our development, and you guys can follow along with what we're doing today on this website. It's called js.do. It's completely free. We don't have to register or anything like that. But we'll be able to, on the left-hand side, enter some JavaScript, execute it, and see the results on the right-hand side. So it's pretty self-contained, just to kind of play around with some JavaScript. The first thing I want to talk about before we get to any of the details, all the syntax stuff, where do the commas go, where do the periods go, where do the semicolons go, all that sort of thing, is kind of the theory of programming. Because programming is weird. If you know HTML and CSS, some of you do, some of you don't, that's okay. That's really declarative. You just kind of describe what you want to have happen, and the browser makes it happen. It makes the web page like this. You don't really have to do any coding. You're just kind of typing in the basic skeleton. The browser takes care of the rest. JavaScript is different. JavaScript is very procedural. Things happen one step at a time, not all at once. In a web page, you make your HTML, the browser just displays it. Kind of happens like magic. JavaScript only does exactly what you tell it to do. And it's really easy to go wrong in JavaScript. The biggest problem I find that a lot of students tend to have when it comes to JavaScript programming, I think we had some people who have a little bit of Java background, some C#, stuff like that. Those languages don't suffer from what we're about to talk about. But JavaScript really can stretch your ability to wrap your head around the following concept: fourth dimensional thinking. Because JavaScript happens sometimes now, sometimes it happens in the future. It kind of depends with event handling, especially when we're dealing with web pages themselves. But the first thing we're going to talk about when it comes to JavaScript itself is, what is it for? What do you think JavaScript's for? We're going to go with Trey, because I know Trey. What's it for? That's one thing it's for. Did you know that JavaScript can actually be used on the back end, on the server side as well? So not just on web pages. There's a whole nother branch of JavaScript development that's actually used someplace else. But you're absolutely right. On the front end, on a web browser, that's the primary problem space for JavaScript. That's where we use it all the time, is on the front end. We're not going to talk a lot about that. Maybe towards the end of this session, we'll get into a little bit of how to use JavaScript to manipulate web pages. We're going to stick, for the most part, strictly to core JavaScript as an independent computer language. We're going to try to stay away from anything too fancy. In order to see what's happening, like what this little sample is doing, we're going to have to actually maybe get into some HTML, but we'll keep it to the minimum for those people who don't have any experience with that. In all programming languages, the number one important concept is data, variables. If it weren't for data, programs don't have a whole lot to do. Data is how you remember things. It's like your memory in your head. If you know what your address is, you memorize that. In a program, you memorize things by storing them in something called a variable. A variable is just a little piece of storage someplace inside the computer. You don't know where it exactly is. You don't really care. It's just a memory. It's going to maintain whatever you tell it to remember automatically. So if we go to js.do, you should see a page that looks exactly like this one. And I'm just going to get rid of everything so we can start all over again. Since the only thing we're going to be talking about today is JavaScript as it pertains to running inside of a browser, inside of a web page, we do have to have a tiny little bit of HTML, which is this HTML. And just briefly to describe what this is, everything in HTML is a tag. A tag is inside the little angle brackets. Tags are kind of like apps at the Apple App Store. If you want to do something on a web page, there's a tag for that. This is a tag that says what's inside. Here's my beginning. Here's my end with a little slash on it.
This might be stupid. Would we put this in our HTML section, or would this be in the JavaScript section?
We'll get there. This tool kind of hides all that stuff away from us, so we don't have to have an entire web page. We're going to stick strictly to this script block, at least in the beginning, to talk about JavaScript syntax and how we structure it and what the important little bits and bobs are. So that's just an empty script tag, and in an HTML page, this would be typically in the head section. Doesn't have to be, but typically it's going to be in the head section. And it just delineates from the rest of the web page, this is my program part. This is my JavaScript part. So that's a little bit of boilerplate tags that we have to have. Anything between those two tags, the begin script tag and the end script tag, is going to be our JavaScript. To declare some memory, a variable, we use the keyword. That's just kind of like a tag name like script. In JavaScript, there are certain words that are important that have various meanings. This is a variable declaration. The variable declaration is just memory. It's something that we want to set a value to. We want to remember what this value is and use it later. All variables in JavaScript use this keyword. Unlike some other languages that some of you guys said you knew, like Java or C#, where variables have types, like numbers or strings. In JavaScript, all variables are declared, which is what we're doing here, with this keyword called var. What we put into that variable determines what type of data it is. Is it a number, like 1? Because we can do math on numbers. We really can't do math on text. I can't really add 1 plus 3 if it was text. I can add 1 plus 3 if they're numbers. So the rest of this first statement, we're declaring a variable with the keyword var. Its name is the next part. Name can be whatever you want. Typically, it's going to be letters, maybe some numbers. There's some other stuff you can throw in there, but let's stick to the simple variable names in this case, which are just going to be strings of letters. They can be 1 letter, 10 letters, 15 letters, whatever you need. So that's declaring this particular piece of memory. And we're going to call that piece of memory X. And we're going to assign to that piece of memory with an equal sign a particular piece of data, in this case the number 1. And then we have a little bit of syntax at the end of semicolon. Technically in JavaScript, and this is the only time you'll hear me say this because I think it's evil, technically in JavaScript semicolons are optional. I don't really have to have this on the end, but it's really, really good idea to always do it. Every time you're done with one thing in JavaScript, to put a semicolon on the end. It makes it nice and delineated that you know that that statement, that one thing, is done. So there we're declaring a simple piece of memory called a variable. Its name is x in this case, and we're initializing it, we're assigning it with an equal sign, a value of 1. Any questions on that concept of memory? That's all we're doing. And these variable names can be as complicated as we want. Oh, let's say this is going to be something a little bit more complicated. Now we're declaring a second, different from x, a second variable whose name is account balance, and I'm assigning it with an equal sign a value of a real number, not an integer, a whole number like we did up here. This is a real number, a decimal number, 12.34. And that number could be big. It could be 1,274,000,000.3456789. You could have a bunch of decimal places. It's whatever you need, unlike some other languages where you can be really specific about how many decimal places you can have. JavaScript stores everything a little differently. But there is a monetary amount. This is kind of a bad idea. Monetary amount, decimal numbers in JavaScript, and this is kind of technical, but decimal numbers are imprecise in a computer language like JavaScript. And so 12.34 is going to be 12.34. A little bit more syntax. Now let's make a third variable, a third piece of memory, whose name is test, and its value is 0.1. And since it's a number, we can do some math on it, just like we learned in grade school. Now I'm going to make another variable, whose name is result, and I'm not going to assign it a simple thing, like a number. I'm going to assign it an expression, an arithmetic expression. In this case, that expression is the multiplication of two variables, in this case, test by itself. Anyone want to hazard a guess what the result variable after this is? What is 0.1 times 0.1? 0.01? You would think it's not, because decimal numbers in JavaScript are imprecise. Let's actually prove that. If I could type, I'm really having trouble. For right now, I don't want to spend a lot of time talking about what line number 6 is doing, but this is going to put the result, the value of the result variable that we just computed, and it's going to stick it over here when we execute this. So I will run that code. And sure enough, result is not 0.01, it's 0.01, a whole mess of zeros, and a 2, because decimal numbers in JavaScript are not precise. It's something to be aware of. Everybody get that result? You ever seen that before? That sort of rounding problem? Mm-hmm. It's a classic. Did you get that?
Is it all computers are
It's because floating point numbers like this, decimal numbers, in a language like JavaScript, and this is true of most languages, is represented with an approximation, It really doesn't have anything to do with the fact that it's a binary. It has to do with the fact that this is a floating point approximation. And it's kind of technical to go into the details as to why. But the important thing to learn from this is that if you want to have a JavaScript program, and that JavaScript program is going to deal with decimal numbers, and you're going to do some math on those decimal numbers, that math might not turn out to be exactly correct. It's close, and there are ways we can get to, we're not going to talk about them today, that we can round this off. Because if I were to round that number and say, I don't care about anything after the second decimal place, that would just go away, and I would have the right answer. We're not going to cover today how to do rounding, but whenever we deal with variables in JavaScript, one of those types of variables could be a decimal number, and rounding, this approximation problem, is something to be aware of. But the important thing to remember here is that variables are just memory. In this little bit of JavaScript, how many pieces of memory, how many variables have we made so far? 4. We've got 4. And they're all completely separate from each other. X and account balance and test and result are completely independent locations in memory. And just because we assigned a variable like X doesn't mean we can't give it a different value in the future. Notice that I don't have the word var, the keyword var, in front of this one. You only have to declare this piece of memory, this variable, one time. You don't have to do it multiple times. So line number 2, I make this piece of memory called X. Line number 3, I change whatever is being remembered by that name X. So now the variable X after line 3 does no longer have the value 1, it has the value 2. It would be completely okay to do this. JavaScript's not going to care, unlike some other languages, but it's totally redundant. That will still execute just fine, and it's still the exact same variable X. JavaScript kind of remembers the fact that you've already declared this piece of memory, so if I do it again, it just kind of ignores us. But much better form, you don't want other programmers to laugh at you after all, much better form is to only declare your variables once. So any questions on these simple numeric variables? Pretty straightforward. And of course, any of the sort of math that you learned in grade school, you could do. We can do addition, subtraction, multiplication, division, a lot of other stuff. If we want to get fancy, we could do sines and trigonometry functions. But all the basic math is there. But in addition to having these sorts of variables, simple number variables, we can have text strings as well. And text string has a little bit of extra syntax. Unlike numbers, which are just digits, and maybe digits with decimal points, text variables, string variables, are bounded by quotes. Optionally, they could be bound by apostrophes. JavaScript doesn't really care, so this would be the same. I can say my text string is inside of the apostrophes or my text string is inside the quotes. I can't mix and match though. That would not be valid. I can't start my text string of characters with a double quote and try to end it with an apostrophe. That would just cause him to complain. But text strings are different than numbers. And again, notice that that keyword is the same. It's still a var. Whether it's a number or whether it's a text string, I still use the keyword var. Text strings, I can't do math on. So if I were to have this, so let's change this slightly. Totally change it. So now I have 3 new variables here. First name, which I assign that text string inside of double quotes, semicolon on the end. Last name is a var. I give him Smotherman with apostrophes instead, no particular reason, just because. And then I try to add those two text strings together. Now, the guys who know JavaScript, what's going to happen? Pardon? Concatenation. So this looks like math, right? It looks like I'm adding something together. But if the values of the variables are not numbers, if they're strings, that just means concatenate them or add them together one after the other. So that will end up with just Kent Smotherman all together. So if we try to test that, we get our first document right, which was our number, and then we get just Kent Smotherman jammed together. That can be super confusing, because that means that what that does depends on the value inside the variable. That's really, really confusing. Most languages don't do that. Now let's change this, just to demonstrate that point. Make a slight change here. So I'm going to take that result variable, and I'm going to say its value is test plus test, which should be 0.2. We write that out, and now we make two string variables with text inside of them, and then we still add, but now we add the two text variables, and we're still going to get that. And it's just, to me, I don't know about other coders, but to me that has always seemed to be super, super confusing. The fact that the plus sign in JavaScript, and it does the same thing in Java and C#, it does two different things. Weird. Got an error?
No. How'd you get it to just be 0.2 again?
I changed the multiplication to a plus, just so that we could clearly see the fact that the plus sign changes its behavior based on whether it's adding numbers or if it's adding strings. Kind of weird. That makes it really hard to figure out what a single line of code was going to do. I've also been doing something that's pretty common. Did you guys get it? I've also been doing something that's pretty common, I haven't talked about. Anyone know what the way that variable name is written? Does anybody with some programming experience? What's it called? Camel casing. This is a really common thing in programming languages. It's changed over the years. I'm a super old guy, and so I remember when they invented camel casing. But there used to be some conventions before that. That's all it is. It's a convention. It's something that most programmers do in most languages so that you can tell immediately what something is. I know this is a variable, even if I didn't see anything else. If that's all I saw, I know it's a variable because it starts with a lowercase letter. And if it's multiple words, every subsequent word in that name has an uppercase letter to make it a little easier to read. But it doesn't begin with an uppercase letter. That's reserved for something else that we may or may not have time to get to. We'll see. And I followed that all the way through. My last name variable, my first name variable, I made sure I camel cased them consistently this way. So some of you other programmers, do you know what they used to call this? What the convention was before camel casing. You guys remember? Ever come across that at all? Mm-hmm. Well, back in the 80s, what was really popular was something called Hungarian notation, which was really goofy. I like camel casing. It's a lot more straightforward. Now, line number 7 and line number 11 are something equally important to variables, but they're not variables. Those are function calls. So right now we've written one big block of JavaScript code. It starts here, and when we execute this, in this case when I click that run button, it does this, then it does this, then it does this, on down the line, one step at a time. That's all it does. But if I want to take a bunch of code that serves some purpose, like this code is doing, and I want to reuse it, I want to organizing it in some way so that I don't have to keep doing it over and over and over again. That's called a function. And document.write is one example of a function. But let's see what that looks like when we describe it ourselves. Instead of saying var, we say function, because we're not defining a variable, we're not defining a piece of memory. Now we're defining a block of reusable code. And a block of reusable code is called a function. But like a variable, after that keyword, so the var keyword is followed by the name of the variable, the name of the memory that we want to use. After the keyword function, we use another name, like add numbers. That's going to be the name of this function. Notice it's camel-cased just like a variable name is. It's camel-cased exactly the same way. Starts with a lowercase letter. If it's more than one word, every word after that is uppercase. He's got a little bit more syntax. He's going to have some parentheses and some curly braces. This is a bare minimum of a function. And it's kind of like this script block. In HTML, we have the script block, we have the end script block. Everything in between is JavaScript code. In a function, we have a keyword function, we have the name of the function, we have these sets of parentheses that we're going to talk about in a minute. Then we have a pair of curly braces, an open curly brace and a closed curly brace. And kind of like that script block, anything that's between those curly braces is a JavaScript code that is related or is encapsulated by this function name. It's one block of code, just like the script block is a different block of code. What goes here is optional. You don't have to have anything between those parentheses. A lot of functions do, and it's called an argument list. It's kind of like a list of variables, except for we don't say var like we do in our normal variables up here. We don't say var in here, but otherwise, we have a comma-separated list of variable names. These work just like this, except for they're only known, they only have meaning or values inside of this function. They don't exist outside of this function. It's kind of weird. And we don't say the word var. But now we've made two new variables for this function. These are the arguments, also called parameters, to this function. So just like here, this is an example of how we call a function. We have the name of a function, we have parentheses, and we have whatever value gets substituted for this variable. That's a really weird concept. So if I wanted to call this function, I just use the name of the function, my parentheses, and then since this function wants two different values to be given to it, I had to give it two different values, like that. I want to make sure you see the correlation between invocation of a function and the definition of the function. Here I'm saying I'm going to make this thing just like I'm making a variable. I'm going to make a function. Its name, how I use it, is going to be called add numbers. It expects to be given two pieces of data, number 1 and number 2. What these names are, totally doesn't matter. It's up to us. They ought to be meaningful. They ought to be something that you can kind of look at and tell what it's for. Here I'm going to add numbers, and the numbers I'm going to add are number 1 and number 2. And then this is the execution of this function. This just makes the function. Nothing happens yet. A function is just a definition of some code that I want to execute some other time. And that other time is right here when I actually use the function. I don't have the keyword function anymore. I just have the name of the function. Then I have the arguments, number 1, comma, number 2, and then I don't need my curly braces because I'm just executing it. I'm saying I want to take that function and now I want it to do its job. I want to make sure you see the correlation between those two lines of code. It's kind of a weird concept. Does that make sense? Make sense? Uh-huh.
So do you necessarily have to declare 1 and 2, or you don't have to recite the...
These are literals. And so if I ever just have a number, that's just a number. JavaScript knows what a digit or a series of digits is. It's a number. This is a whole number or an integer. This is a decimal or a floating point number. But it knows what that series of numbers is. Just like if it sees apostrophes or double quotes, it knows that that literal is a string. So here, these variables have to be given values when I call this function. I call it here. I have to give it values. I can give it literals, or I could give it variables. So instead of saying 1 and 2, I could say x and 2. Same thing. So when I make this call, the value of x, when this executes, I start here, I execute down, I get to here. What is the value of the variable x? Nope, 2.
Oh, yeah, okay.
Because we assigned it, and then we changed it. Yeah, kind of crazy. And so when I execute add numbers, and I go into this function, what is the value of the variable number 1? 2, because number 1 came from x, and x had a value of 2. But this block of code, whatever code's going to go in here, we'll put some code in here in a second, whatever code that is, I only have to write once because it's a function. I can use that function, giving it different pieces of information as many times as I need to. Super, super handy. I got a block of reusable code now, and that block of reusable code is called a function in JavaScript. In other languages, sometimes it's called a method.
Does it matter about the order? Would we define our function before trying to use...
That is an excellent observation. Let's see what happens. But first, let's put a value in here. Let's put some code inside this function. What do you think the job of this function is, given its name? It's going to add those two numbers together. That's his job. This is a great example of choosing meaningful names. The names of our functions and the names of our variables ought to make sense based on what they represent. Here, this function's job is to add two numbers. So that's the basic job of this function. But unfortunately now we have to talk about the single, well, I shouldn't say the most, the second most confusing part of JavaScript, of any language, scope. Scope is weird. Yeah, you know what I'm talking about. Scope is weird. Scope is really, really weird. I've been ignoring it till now, but inside this script block, and again, to your point earlier, this is actually part of a web page. We're just kind of ignoring the rest of the web page. But inside this script block, all of these variables, including this function, is in the global scope. Scope is kind of weird. That means any place inside of this file, inside this web page, those variables can be used. They can be seen. But it's global. It's not hidden away any place. Any place in this file could use it, including if I were to do this. I'm going to get rid of some of these blank lines just so we can see all this. That'll be good enough. This variable x is the same as that variable x. They're both in script blocks. They're both in the global scope. Does that seem weird? Does that kind of make sense? You just have to kind of take my word for it. There's this thing called global scope. So it's kind of like, since we're using the memory analogy with these variables, if I were to take some information and post it on that wall, that's global. We can all see it, we can all use it. But the information you have in your head, that's not global. I don't know what that is unless you tell me. And we're about to get to that, because it has to do with this thing called a function. But global scope is just like a note on the wall. Anybody can see it. Anybody in this program, this web page, can see anything that's global. Anything declared inside of a script block is global. This is where it gets confusing. Are those variables, which are special, they don't have the word var in front of them because they are function arguments. There's something I declared as these arguments, these options to this function. Do you think those are global?
No.
Why not?
Because they're only in existence in a function. They're not declared outside of a function.
Right. It's kind of confusing, but these variables here are local to this function. Outside that function, you don't know what they are. They have absolutely no meaning. So unlike the note on the wall, it's the information inside somebody's head. You could ask them for it, which is what we're about to do. But otherwise, that's a delineation between variables that are global and variables that are local. And that is the only distinction of scope in JavaScript. Other languages have all kinds of different scopes. C#'s got different scopes. Java has all kinds of different scopes. JavaScript only has these two. Everything is either global or it belongs to, its scope is the closest function that contains it. That's the only two scope rules in JavaScript. There are no other. So since these are declared inside of this function, they only can be seen, they can only be used inside that function, which means inside his curly braces.
Can we use global scope and local scope? Can we put those in there, or would that get
Well,
confusing after a while?
the information inside your head is private. The information on the wall, like that caution sign, is global. Can you read that sign? So you can. Global information doesn't go away inside of a function. But these variables don't go away, they do go away outside this function. You cannot see them. They're only part of this function. As if that weren't confusing enough, in addition to these variables, these arguments that I'm defining for this function, I could go ahead and make another one. Oops, I don't want to save. But since this variable, which is inside the function, and again, inside the function means inside those curly braces that bound the function, anything that's not an argument needs to be another variable. But that's not a global variable like that is. because it appears inside the function. So that variable is local. It has no visibility, it has no value even outside of this function. Kind of weird. But that, line number 16, is not very useful yet, because the purpose of this function, if I say I want to know the answer to x, which is 2, plus 2, which is what this is doing. If I want to know the answer of that math, I have to get that answer and get it out of this function, because I'm in the middle of a function. I can't see anything inside of here. It's local to those curly braces. So I have to get that result, that value, out of this function. And there's a keyword for that. It's called return. Functions don't have to return something. Most of them do. Whenever a function encounters a return, it's done. Nothing else will execute after that return statement. So if I were to put something else, like that line, line number 16 in this case, oops, I got rid of my return. Oh no, I didn't, it's on number 15. Line 16 will never happen, ever. No way to make it happen. Because once I return an answer from a function, that function is done. He's done his job.
Wait, so you can't return two things, so it immediately breaks that.
Well, I don't know how to answer that without giving something away. But technically, yes, you can only return one value. That value might be complicated, but you can only return one thing. I can have more than one return statement if I have some other stuff we haven't looked at yet. But in general, if I'm in a function and I get to a return statement, that function is done. Nothing else after that's going to execute. So line 16 in this case will never happen. And when I return from a function, and I return an expression or just a simple variable, whatever it is that I want to return. In this case, I'm returning the result of this math. When I return that, it replaces this call. So the result of calling add numbers for x and 2 is whatever this thing returned, in this case 4. And I can do anything with that value that I want. Typically, I'm going to assign that. I keep wanting to hit save. I could assign that to some other variable, like in this case, a brand new variable numResult. And so the value of that variable would be 4. X was 2, last we knew. We pass in 2 and 2, so number 1 is 2, number 2 is 2. We add those two together and return them, so numResult ends up with a value of 4. And we can try to answer the other gentleman's question next by trying to output that. So we can verify that its value is 4. But, what was your name again? Ryan. Ryan raised a really interesting question, which is, if JavaScript executes one line at a time, from top to bottom, one by one, does what we tell it to. When I get here, I haven't got to this yet. So does it know what the function add numbers is? Place your bets. What do you think? Yes or no? Let's find out. Hey, look, it worked. This is why programming languages are really confusing. They break their own rules all the time. And if we have time towards the end of this session, we'll see some really crazy examples of how JavaScript will break its own rules. But here, this code executes this way, but it knows what functions are, even if it hasn't gotten down to them yet. It's kind of weird. It's just something that JavaScript does. But it makes logical sense. It makes absolute logical sense that the answer would have been no. It doesn't know what that function is. And there are older languages. Again, I've been a coder since the 70s. And back in the 70s, there were lots of languages that didn't do this. If I wanted to use a function, I had to put the function first, and then I could use it. Most modern languages don't really care. As long as it's in there somewhere, it'll find it. Kind of weird. So the concept of a function makes sense, and how to use it, or why we want to use it. Functions are incredibly powerful, because I can write my code once, and I can use it with different arguments anytime I want. Really super powerful. You guys have any questions on variables or functions before we get into the hard stuff? Easy crowd. Or, I shouldn't say that, smart crowd. That's what it is. Not an easy crowd, it's a smart crowd. This is all fine, but programs are pretty useless unless they can make decisions. That's what makes programs smart, is the ability to make decisions. And I would argue it is the single most important aspect of any computer language. It's pretty simple too. Making a decision seems pretty intuitive. I need to be able to do something or something else based on something, like maybe the value of a variable. And just like everything else we've seen in JavaScript, there's a keyword for that. I want to make a variable, I say var. I want to make a function, I say function. If I want to make a decision, I say if. Let's clean some of this up. Well, now we'll just keep going. And you'll notice I tend to write code this way. Just like I wrote the function, I do the skeleton, I do the absolute minimum first, and then I go back and fill in the details. That prevents me from making mistakes, like forgetting my end parenthesis, forgetting my end curly brace, because right now it's really simple. That's the minimum if statement. If something, then execute some code. Kind of like a function, the code that I'm going to execute is inside of those curly braces. What goes inside of here can be kind of a strange concept. It's a Boolean condition. To the point you guys made earlier, everything inside of a computer is a Boolean. It's true or false. Everything. Sometimes you got a lot of layers on top of that, but an if statement is a great example of that. Something is either true or it's not true. And whatever I want to compare, whatever I want to check, goes inside those parentheses. So for example, if I wanted to make a decision based on the value of x, I could do a comparison. I say if the value of x is less than 2 in this case, then execute this code, whatever's inside those curly braces. If x is not less than 2, which also means the value 2, if it's 2 or greater, don't execute the code that's inside of those curly braces. And all we're going to do right now is verify that we got there. So if x is less than 2, just write out the value of x. These operators, these comparison operators, can get kind of long. The basic choices are less than or equal to, greater than or equal to, equals, notice there's 2 equal signs, not 1, And in JavaScript, more specifically, you would see 3. We'll talk about the difference between 2 and 3 equal signs a little bit. But simple's 2 equal signs means I want to compare to see if these two things, whatever's on the left-hand side, whatever's on the right-hand side, I want to see if they have the exact same value. If x equals 2, execute line 16, otherwise don't. Sometimes you want to do 2 different things. If it's equal to 2, execute this code. If it's anything other than 2, the else to this if, I want to do something different. Okay, now I don't want any fist fights to break out, but what we're about to talk about, I've seen people come that close to blows of what we're about to type. I'm not kidding. You ever seen this art? You've seen people get this passionate about this sort of thing? It's crazy. So literally what I'm going to do is say, if this statement is true, if x equals 2, do this. Else, if it's not equal to 2, do something else. Maybe change the value of x. And what coders, I should say, because coders are not always people, what programmers argue about is, where does the else go? It's kind of silly. Does it go here, or does it go up after the curly brace? I'm not kidding. I've seen people get really upset about this. It is kind of funny. I don't even know if I would say there's a standard, but you might see it that way too. If some condition, some block of code, else a different block of code. Didn't it? Woo. Yep. Yeah, I tend to agree, although it does save space. If you do it the other way, you save a whole line in your source code. Is it important? I would say not. If you get a job programming, it'll be a standard. That company will just declare you always do your else's this way, or you'll always do them the other way. And you will actually be judged on your job performance if you follow the correct standard. It's crazy. And then you'll get another job someplace else and they'll do it exactly the opposite. And you have to break your habit and do it the other way. Yeah, kind of silly. So to review what this is doing, I'm going to change this to be a little broader. I'm going to say if it's less than or equal to 2, do the first block of code. Else, if it's not less than or equal to 2, which means it's greater than 2, do the second block. But maybe I want to do another check, which I can do. I can keep chaining these on to each other. If it's less than or equal to 2, else if it's less than or equal to 5, else. I think the most I've ever seen, if, else if, else if, else if, is somewhere in the vicinity of a couple dozen in a single block of code. There were a lot of decisions to make. The generic colloquial term in programming for this is called an if ladder, because when you look at the code, it looks kind of like rungs on a ladder. This is called an if ladder. When you have an else, an if, an else if, maybe some more else ifs, and then finally at the end, an else for everything else. Decision making. That's pretty simple decision making. Pardon? Are you lost? Is it not executing? Hey, I haven't tried running this. I might have a mistake. Let's take a look. I have not tried executing. Nope, mine executes. Programming is, I like to say, I teach another class, Interface Web School. I tell all my students in that class, programming is not about being smart. It really isn't. If you want to be a good programmer, the number one skill you need to develop, and it can be developed, you don't have to be born with it, is attention to detail. Where do the semicolons go? Where do the end quotes go? Where does all the little bits and bobs, the syntax go? Because I have wasted hours trying to figure out a problem, and it was just one character that I had in the wrong place. Attention to detail is your greatest asset as a developer. Being smart, that doesn't hurt you any, but attention to detail is way more important. Unfortunately, a lot of it's memorization. Where do all those little symbols go? So when we execute this, we should see output like this. Our final answer was 2, because the value of x was equal to 2. 2 is less than or equal to 2. So we wrote out that 2, and we did not change it to 5. So that should be the output you get. So these if statements, the conditions, which is what's between the parentheses, these are very simple. I'm comparing one variable to one value. But a lot of times, the decisions that we have to make in programs is a lot more complicated. It's not as simple as if x is less than 2. Maybe I want 2 different conditions to both have to be true. So this bit of syntax is now making this condition of the if statement a compound condition. We're saying that not only does the value of x have to be less than or equal to true, but also, and, 2 ampersands, you read as and, this has to be true, and this comparison has to be true. Account balance must be greater than 0. And those can be as complicated as you need. There is literally no limit. You could have 10 different conditions inside of an if statement, as many as you need. This is a simple and. Its corollary is 2 vertical bars, which is an or. So now I'm saying either condition has to be true. If I had ampersand saying and, this entire if statement is only true if every component is true. If I say this or this, either one could be true, and the if statement would still be true. And an or. Does that make logical sense? Seem pretty straightforward? Ands and ors are pretty familiar. What about this? Now it's getting a little harder. If I mix my conditions, let's see, on your keyboard, yeah, right there, shift that. So now this if statement's getting a lot more complicated. We're saying if x is less than or equal to 2, or account balance is greater than 0, and test is equal to 0. How do you think these relate to each other? In what order are each of those comparisons going to be made? Because it's really important. Think so?
Yeah.
I don't. These expressions, everything we do when we're relating 2 different parts of a statement, whether it's a plus, whether it's an equal sign, whether it's a comparison, whether it's an and or an or, they have an order of operation. They have a precedence. And to your point, some of them are more important. Some of them will happen first. Some of them will happen last. Ands and ors have the same precedence, which means they execute left to right. These comparisons have a higher order of operation. They are more important than these. And so first, that's going to happen. It's going to do this comparison. If it's true, if x is less than or equal to 2, is there anything else logically that you think has to happen? Pardon? It's going to have to do this, but is it going to do any of this? Exactly. Why? Why is there no point? It's already fulfilled its condition. These operators, comparisons, are more important. They're going to happen first before these. So this is going to be evaluated. X is 2, so x is less than or equal to 2. So this is true. Then it sees an or, and it says, I don't care if this is true or not, because this is true. And if I have an or, if the first one is true, I don't care what the second one is. That's really important. And so the rest of this doesn't happen. If the first expression were false, now it has to keep going, because it doesn't know if maybe that's going to be true. But once it gets past this, if this is false, now it's going to have to evaluate both of these because they're joined by an and. How confusing is that? Fortunately, there is something you can do about that, and I recommend that you always do it, because then you never have to go through the exercise of thinking through what is the order of these execution elements, these little pieces, what's their sequence going to be. You can group them. I could put that part inside of parentheses. And now I've broken the rules. I say this is going to happen together, because I put it inside of parentheses, before I do this. Now, as it turns out, did I change anything? Is that the same? Is it going to do the same thing as it was going to do before, without the parentheses?
No.
Why not? Mm-hmm. Because now I've only got 2 conditions. I got 3 total, but as far as the computer is concerned, I have that condition, because it's inside of a parentheses, and I have this condition. So if this one is true, if either one of those is true, this still has to be true, because as far as the if statement is concerned, that's one thing, and that's another thing. And they're joined by an and so they both have to be true. Super confusing. If statements can take a little bit of time to get used to because of that. They can be complicated. Does that make sense as to why that changed? All we did was put these parentheses there, and we changed the entire way this expression becomes evaluated. Does that make sense? You look like you're on the fence. You get it? Yeah. Ands and ors. Kind of weird. But the most important part of any programming language, including JavaScript, is that. The ability to make decisions. And the more complicated your program, the more complicated your decision making. Those if statements can get really, really crazy. Now let's talk about looping. Right now, this program still isn't tremendously useful. Oops, that's not what I wanted to do. Because this program is still just going to start at the top, do one thing at a time, and fall off the bottom. That's still not tremendously useful. We got some decisions in there, so it's a little bit more useful than it was without decisions. But the ability to repeat actions repetitively, also really, really powerful. We do that. I'm going to do it in the simplest way possible. So right before this, add this function. Actually, let's be more specific. I am a really super old guy. Back in the olden days of programming, variable names could only be 1 letter long. Not very useful. That's why I have a tendency to do stuff like this, which is terrible, because X, what's that? 1 letter is not very self-describing. Whereas account balance, you got a pretty good idea why I have that variable. It's holding an account balance. So variable names should be descriptive. I always have to catch myself and not use single variable names. I'm going to call this one index. They're going to have an expression called a while. So the code inside of these curly braces is going to happen more than once. Unlike everything we've seen so far, which executes only one time, a while loop is exactly that. It's a loop. It's going to execute a whole bunch of times. In this case, it's going to execute as long as, or while, that statement is true. So it's kind of like an if statement. A while loop is kind of like an if statement. The condition must be true for the loop to keep going. And the loop will keep going as long as that statement is true. I also did something else without realizing it. It's worth noting. Anytime I have curly braces, I indent my code. Makes it easier to read. That's a pretty strong convention that almost all languages follow. There are some languages like Python where it's mandatory. If you don't indent your code, it doesn't even work. But in most languages, it's strictly a convention. Here's a block of code with the curly braces, and the code that's inside there should be indented. Easier to see what code belongs where. So in a while loop, the code in between the curly braces, in this case this document right, is going to keep happening over and over and over again as long as this is true. What will this while loop, given that description, what will this while loop do? What do you expect its output to be? Because we are, after all, computer scientists. And the scientific method says we formulate a hypothesis and then we test it. So our hypothesis is, what do we expect this to do? Pardon? It's going to do what? It's going to forever, and I do mean forever, or he means forever, it's going to print 0 forever. It will never stop until you close your browser. Why? Don't answer. Why? Why is that going to print 0 forever?
Because it says while it's less than 0, it says 0 is less than 10.
And it's always 0.
It's always 0.
It's always 0. So in a structure like this, there really ought to be, some changing of that variable. So that at some point in time, this expression is no longer true, and the while loop won't run forever. In structures a lot like this, we're going to do something like this. Let's reassign the variable index to index plus 1. So the first time it's 0, the second time it's 1, and then 2, until finally it's 10, and now it stops. There are at least 3 ways to write this line of code. Who knows one of the other 2? Go ahead. So this is the nice, straightforward way. I'm going to take the variable index. I'm going to assign it this expression, index plus 1. That is such a common operation, there's a shortcut for it. That's one of them. Index plus plus will do exactly the same thing that we just looked at. It'll take index and add 1 to it. Give me another one. Plus equals. I could do that. Same thing. Index plus equal 1 is the same thing as index plus plus, which is the same thing as index equals index plus 1. One more. There's actually one more way to do this. I got to challenge the guys who know a little bit of JavaScript. There's one more way. It's very, very underused. I can put the plus on the other side. It does, but you said something really important there. depending on what else is going on this line of code, in a line of code this simple, totally the same thing. Plus plus equal, or plus plus index plus plus, all four of those different expressions will do exactly the same thing. Well, I don't want to dwell on this too much, but the way I remember it, this is an expression, just like that's an expression, index less than 10. This is an expression. And the result of this expression is the value of index after the increment has happened. Now here I'm not using the value of this expression. But if I put the plus plus on the other side, the result is the value before the increment, which may or may not be important in what I'm doing. But in this case, I'm kind of throwing away the result of that expression, so it's not really relevant. But now this loop will only execute 10 times if we did our jobs. Let's take a look. There's our values, 0 through 9. How come we didn't see 10? Because 10 is not less than 10. The last time through, when this increment made index have a value of 10, we said only keep doing this while index, which is 10, is less than 10. 10 is not less than 10. 10 is equal to 10. So that's why we did actually see the value 10 printed. This sort of a structure is so common, there's a shortcut for that. Just like there was those different ways of incrementing a value. The shortcut for this expression is called a for loop. We do everything we just did, but we do it in a slightly more compact way. The basic structure looks the same. We have the word for instead of the word while. We have parentheses, and we have the curly braces with some code. This part is actually 3 separate statements. It's this statement, it's this statement, and it's this statement. It's all the things going into looping or incrementing this iterated loop. So first we have to make our variable. Then we have a semicolon, because it's actually 3 different things. Then we have the thing that was inside the while, the condition, semicolon. And then we have what do we change every time. Yep, in this case, any one would work. Index plus plus, plus plus index, index equal index plus 1, or index plus equal 1. All 4 of those, same thing. And then we have our document right. A little more compact. But those 2 loops, while loop versus a for loop, in this case, do exactly the same thing. Just a little bit more compact. And those are the only 2 types of iterating or looping statements, while and for. Of course, a while loop could be more complicated than this. A for loop is going to look just like this most of the time, because it's got some counter, and that counter has a bound, and it has an operation. I'm doing it one at a time. If I want to do every other one, I would say not plus plus. If I only wanted to do this every other number, not every number, I would say plus equal 2, or plus equal 3 if I want to do it every third one. But a while loop can be more complicated, because whatever this thing is might not be a simple incrementing number. It might be something a lot more complicated, especially when we deal with web pages. And so if it's a simple, hey, I've got to do something 10 times, it's going to be a for loop. If I've got, hey, I got to do something and I don't really know when it's going to end, it's going to be a while loop. But the most important thing to remember about that while loop is somewhere inside that code, there better be the changing of this condition. Otherwise, that while loop will go forever. You ever been on a web page and you, like on Chrome, you get the little pop-up with the guy with the XXs on his eyes, and it says, hey, this page is taking a long time. Do you want me to wait or kill it? That's what happened right there. More than likely. There are a couple of other explanations. But more than likely, some loop was going millions and millions and millions of times, if not forever. And the browser, like Chrome, said, I'm going to give it a little while, and if it keeps doing that for too long and doesn't ever finish, I'm going to give you the chance to kill it. More than likely, when you're developing JavaScript, this is the explanation. This index never got changed. The condition was always true, and so it just went. Kind of weird. So those are the two types of looping statements. In fact, I don't think I'm going to talk about the last one. It's not very important. So any questions on anything we've talked about so far? Many of these guys are smart. Uh-huh.
What would the functional application be writing a loop? Like, what's the point of it, or what do you use it for?
I knew somebody was going to ask that question. What was your answer?
Taking attendance in class. If this person's
Sure.
going down the line. And
Although that implies something we haven't talked about yet.
well, just like a rule, yeah, if you're
Right.
doing
Where do you get the list of students from? Challenge. So the last couple of things I want to talk about, to answer, I think, Ryan's questions, which was, what do we use this for? So these while loops and whatnot, what are you going to use that for? Let's see how to drive a while loop with data, rather than just kind of arbitrary example, which is just counting 1 to 10. In order to do that, we have to have a higher level object, higher level data. Right now, we've got one thing, a variable. That's all we've learned. One variable holds one thing. That's all there is to it. Nice and simple. It's kind of the backbone of programming, but we want to do something a little bit more complicated than that. The simplest thing that's more complicated than that, which I'm going to take out this loop temporarily. I'm going to do it with a block level comment, which we haven't talked about yet. So if I take some code, some JavaScript, and I bound it on the ends with a /* and end it with a //, all of that code is now gone. It's a comment. It doesn't actually execute anymore. That's a really common thing programmers will tend to do, because it's like, you know what? I want to mess with this. I'm not entirely certain what I want to do, but I don't want to delete it yet because I might want to use it later. So you just take it out temporarily with a comment block. I could also take this out one line at a time. That's a block level comment. I could take it out one line at a time instead by putting a // at the beginning of each line. That comments out each individual line of code one by one. But if I have a whole block of code I want to temporarily take out, that's a lot faster. Just wrap it, any part of it, with a /* and a //, and it'll go away temporarily. Now let's make a more complicated variable. It works just like a normal single named variable. Let's call this variable students. But now, rather than assigning it one thing, we're going to assign it a whole bunch of things. And sometimes this can be hard to read. Those are square brackets. And that means an array or a list of values. Not one value, but an entire list of values. So it works just like a variable. It's still memory, but instead of only holding one thing, now I said this is an array. I say it's an array by the square brackets. And now I give it a comma-separated list of values. It is a super good idea that every type of information that's in this list is the same type of data. They should all be strings. They should all be numbers. They should all be the same type of thing. Nothing in JavaScript prevent you from mixing and matching, but that gets really, really hard to control. It makes a lot more conceptual sense, because what is this data? Students. It wouldn't make any sense for me to say my students are Kent, Ryan, and 5. That wouldn't make any sense. JavaScript would allow me to do it. I can put anything in these placeholders that I want, but because an array is one logical thing, it's got one name, each of those elements in the array ought to be the same type of thing. If they're all numbers, they're all numbers. If they're all strings, they're all strings. But unlike simple variables that I use by just using the name of the variable, like here we had a variable called test, and I simply use the value of that variable by using its name. If I have an array, I still only have one name. So how do I get to Ryan as opposed to Art, given the single variable name students? I do that by using those square brackets again, and I give it a number. In this case, 1. Each one of these array elements has an index. The first one is number 0. And that's pretty common in all languages except CSS, where for some reason it starts at 1. Whatever. But this is number 0. That's students square bracket 0 is Kent. Students square bracket 1 is Ryan. And students square bracket 2 is Art. In order to make looping, for loops in particular, work really well, whenever I have a variable that is assigned an array, I have some special stuff I can do with that variable name. I can say this. I can say students.length. And that means how many things are in this array. In this case, that would be 3. Students has 3 things. That makes for loops now. As long as I have this thing called an array from someplace, now for loops kind of make a lot more sense. Let's change this a little bit. Instead of index, well, I could still say index. It's no longer less than 10. It's less than students.length. Increment. Man, old habits. I keep trying to save everything. So now with this students array that has 3 things, I don't have to know that it has 3 things. I don't care how many it has. I use my for loop to say start at number 0, because that's number 0, and go as long as this incrementing index is less than however many things there are in students.length, and then increment that loop variable to visit each element in the array, 0, 1, and 2. If I had 1,000 of them, this would look exactly the same way. I would simply have 1,000 things in students. But now the for loop remains exactly the same, because I'm taking advantage of the fact that arrays have this thing, which is called a property, called length. Uh-huh.
This specific reason why you have student length number 34 first?
No. No. This was strictly for demonstration purposes. So those 2 lines of code aren't actually doing anything, so I'll just comment them out. Yeah, 33 and 34. So I make my students array, I assign it these 3 things, and then I iterate. I have a for loop that goes through, starting at 0, incrementing by 1, and going as long as that index is less than the number of things, the length of this array. So that will simply print out all 3 of the elements in that array. Cross your fingers, did we do it right? Yes, we did. So there is a good use of a for loop, and this is probably the most popular use of a for loop, is tied to something like an array. Because the array came from somewhere. Where it came from, I don't know. In this case, we just hard-coded it.